Now, previously, we had talked about how we go about writing a fraction with a given denominator, right? Like, maybe we started with the fraction 5/7, and we wanted to write it as a number of 40 seconds. What did we do? We said, well, what do I have to multiply 7 by to get 42? Oh, 7 times 6 is 42. And so if we multiply the denominator by 6, we have to multiply the numerator also by 6. We get 40 seconds. Okay, but that has a limitation, right? I need to know what number to multiply by. I need to find out about this 6. That's not that hard, except sometimes no whole number will do. For example, let's say I wanted to write 31/7 as some number of fourths. That's not going to work, is it? There is no whole number I could multiply, or for that matter divide by, to get from 7 to 4. I could mess around with fractions, but I don't need to because I have this powerful new technique. I can write a fraction with any denominator I like just by solving a proportion. Now, this is not perfect, right? The fraction may be complex. In fact, it typically will be. That's pretty cool, right? I can get any denominator that I want. So let's see. To do that, I want to solve this proportion. Again, I'm using the letter x because that's traditional. I want to take the cross products. 31 times 4, 7 times my unknown number, and I want those to be equal. Okay. Well, I need to work out what 31 times 4 is. That's no problem. And now x is the missing thing in a multiplication problem. I want to use division to find it. I could just answer with the fraction 124/7, but I don't know about you, but I can't tell at a glance whether that's a whole number or not. So I think I'd like to write this as a mixed number. Let's see, 7 goes into 1, not at all. It goes into 12 once. 7 goes into 54. 7 times 8, 54. Checking the multiplication table, no, that's 56. So 7 goes into 54 7 times. 7 times 7 is 49. I have 5 left over. So I get 17 whole things, and I have 5/7 left over. So it turns out that 31/7 is 17 5/7 fourths. We can even do this with a mixed number. If we want to write just any number that's not encountered in the form of a fraction or complex fraction as a fraction with a given denominator, we write that number over 1. So for example, I could ask you to write 4 1/3 as a number of fifths. Seems like a strange request, but we can do it. We'll write 4 1/3 over 1 equals some unknown number of fifths. Taking the cross products, we notice something that makes us really happy, right? If we're using this technique, well, one cross product is 4 1/3 times 5. That doesn't make us very happy. But the other cross product is just 1 times our unknown number. 1 times anything is just the thing itself. So one of our cross products, if we're using this technique, is going to be just our unknown number. So 4 1/3 times 5. I think I need to write 4 1/3 as an improper fraction, right? So 3 times 4 is 12, plus 1 is 13. And it's always going to be a number of thirds. And 5 I'll write as 5 wholes. So I'll have 13 times 5 thirds. No simplifying this, right? Because 13 and 5 are both prime. So I'll have 5 times 3 is 15. 5 times 1 is 5, 6. 65 thirds. I think I probably want a mixed number, just because I seem to be in an environment where mixed numbers are popular. So I'm going to divide 3 into 65. 3 goes into 6 twice. Nothing left over. Bring down the 5. 3 goes into 5 once. 2 left over. So I have 21 whole things and 2 thirds left over. That was my x. Again, it was 1 times x. If I still had to do division to this, would I have made it into a mixed number? No, I wouldn't have made it into a mixed number before I did division to it, because I can't do division to mixed numbers. Let me give you one of these to try. Using the technique we just talked about, write 1.6 as a number of 15ths. Give your answer as a whole number or as a decimal. Pause the video and try this now. Alright, so 1.6 doesn't look like a fraction, so I'm going to write it as the complex fraction 1.6 over 1. And that's going to equal some unknown number of 15ths, right? This word 15ths tells me my denominator is 15. Okay, let's look at the cross products. I have 1.6 times 15, and I want that to be equal to 1 times x. Again, I'm multiplying x by 1. Yay! So that's just x. So I need to multiply 1.6 by 15, and that'll give me my x. 1.6, 15 times 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. 1 times 6 is 6. 1 times 1 is 1. Add them up. And 1 total digit after decimal points up here means 1 digit after the decimal point down here. 24.0. I don't really need that 0.0, do I? I just get 24. So 1.6 is 24/15.